Welcome to today's lecture. This is Lectures on Transformer, Part 3. In Part 3, we're looking at numericals in Transformer. That is, calculations in Transformer. Let's look at the first problem. A transformer has 400 turns in the primary and 100 turns in the secondary. If the primary voltage is 240 volt, find the secondary voltage. Quoting part of the transformer equation, ES over EP is NS over NP. Okay, don't forget we're looking for the secondary voltage, which is ES. So if you cross multiply, you have ES NP is EP NS. Making ES the subject of the formula, you have EPNS over NP. Don't forget the voltage of the primary coil is 240. The number of turns in the secondary coil is 100, while that in the primary is 400. So if you resolve, you will get 60 volt. Question number 2, a transformer has 100 turns on the primary and 500 turns on the secondary. If the secondary current is 2 ampere, find the primary current. Quoting part of the transformer equation, IP over IS is NS over NP. You cross multiply, it will lead to IPNP equals to IS NS. So IP is IS NS over NP. And so then we impute the values given. IS, current in the secondary coil, is 2 ampere. If the secondary current is 2 ampere, so current is 2 ampere, 500 turns in the secondary coil and 100 turns in the primary, and that will give us 10 ampere as our answer. Question 3. A transformer connected to the 240 volt mains supplies a secondary voltage of 12 volt. If the secondary current is 4 ampere, calculate the current drawn from the mains. There is a new word used here, so I want you to note it. The word mains refers to the AC power supply from the electricity authority, and this supply is connected to the primary coil of a transformer. So the word mains, 240 volt mains, is connected to the primary coil. So then, quoting the transformer equation, ES over EP is NS over NP equals to IP over IS. In this very question, we do not have any parameter on number of turns in the primary or secondary side, so we will ignore this one and we go with just these two. We are required to look for the current in the primary coil in the mains. So if we cross multiply and make IP subject of the formula, we come up with ESIS over EP. The voltage in the secondary coil is given as 12, while the current in the secondary coil is given as 4 ampere. The voltage in the primary coil in the mains is given as 240. So if you resolve this, you get 0.2 ampere. That will take us to question number 4. A transformer is connected to the 240 volt mains and steps up the voltage to 2400 volts. 240 volt means that's EP. Steps up the voltage to 2400 volt, that's ES. If the mains current, that is IP, is 5 ampere, find the current in the high voltage transmission line. That means we are required to look for IS. The transformer equation again, we do not have any parameter on number of turns, so we ignore the number of turns and we take this 2 and then cross multiplying and making IS subject of the formula gives us EPIP over ES. And we'll forget that the voltage in the mains primary coil is 240, current 5, and the voltage in the high high tension transmission is 2400, and if you resolve this you will get 0.5 ampere. Question number 5. A transformer connected to the 240 mains has an input power of 600 watts. If the output power is 510 watts, calculate the efficiency of the transformer. Don't forget, efficiency of a transformer is output power over input power times 100%. We are given the output power as 510 watt, input power as 600 watt, multiplied by 100%. If you resolve this, you will get 85%. Question 6. A transformer is connected to the 240 mains. It supplies a voltage of 24 volt to a load. The load has to do with the secondary side of the transformer. If the current in the secondary coil is 5 ampere and the efficiency of the transformer is 80%, calculate the current drawn from the mains. So again, efficiency is power output over power input times 100%. Don't forget our power output is ESIS, our power input is EPIP, and then times 100%. We're given the efficiency to be 80. The voltage of the primary coil, that is the load, is 24. The current is 5 ampere. The voltage in the mains is 240 times IP, which we're asked to look for, then everything times 100%. Just swap position, that is make IP subject of the formula. IP is 24 times 5 over 240 times 80 times 100. Having cancelled out the percentage, okay, you just this percentage here, you cancel it out. So if you resolve this properly, you're going to get IP is equal to 0.625 ampere. Take a look at it. 80%, 100%. See the symbol for percentage is cancelled out on both sides. Don't forget. And so you now resolve for IP. I will urge you to attempt the following questions. Question 1. A transformer is connected to the 240 volt mains and supplies 12 volt to a load. If the secondary current is 6 ampere and the efficiency of the transformer is 75%, calculate the current drawn from the mains. Question 2. A step-up transformer connected to the 240 volt mains produces an output of 2400 volt. If the current drawn from the mains is 4 ampere and the efficiency is 90%. Calculate the current in the secondary coil. Question 3. A transformer connected to the 240 volt mains has 1,200 turns on the primary coil and 300 turns on the secondary coil. If the current drawn from the mains is 2 ampere and the efficiency of the transformer is 80%, calculate the secondary current. And lastly now, a transformer connected to the 240 volt mains supplies a high voltage line at 2400 volts. The load consumes 900 watts and the transformer has an efficiency of 90%. Calculate A, the input power from the mains, B, the secondary current. I urge you to try to solve the following problems. This will bring us to the end of the lectures on transformers.